Hello everybody, I am Ashoke from AKB Tutorials. You are welcome back to my channel. In this channel we are discussing various topics related to mechanical engineering. Now we'll see one of the most important topics of strength of material, that is principal stresses. So before going to principal stresses, we will just see that complex stress system. So this is the most complex stress system acting on a body, that is sigma x stress acting along x direction, sigma y stress acting along y direction. Along with that, the shear stresses are also acting on the element. So tau xy, in this case tau xy is acting in anti-clockwise sense on x phase and tau xy in clockwise sense on y phase. So we have derived this formula, and the results of the derivation we have got sigma n and tau. Sigma n is given by sigma x plus sigma y by 2, sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta. Tau is given by sigma y minus sigma x by 2 sin 2 theta, tau xy cos 2 theta. So those who have doubt or have not seen, so you can refer last video, so there you will get the derivation of this. Okay, so today we are going to study the principal stresses. Now say this is the body. We have considered an inclined plane at an angle theta, where we have seen that sigma n and tau is developed. Now if we consider another plane whose angle made by the plane with x-axis is different, so sigma n and tau value will be different. Similarly, we can assume any number of planes from 0 to 90 degree. So if we consider planes from 0 to 90 degree, the value of sigma n and tau will carry on changing. So that means on the plane sigma n and tau, it depends on your theta value, because cos 2 theta and sin 2 theta is there in sigma n equation. Similarly, in tau equation, sin 2 theta cos 2 theta is there. So that means the magnitude of sigma n and tau will vary from plane to plane. Now there will be some plane where tau is 0. So that plane is known as principal plane. Now we will first define what is called principal plane. So principal plane, the plane on which shear stress is 0, on which shear stress is 0. That plane is known as principal plane. On principal plane only normal stress will exist. So shear stress is 0, so only normal stress will be there on that principal plane, and that plane is known as principal plane. Okay, so the plane on which shear stress is 0. Now how to get that plane? So shear stress we have got sigma y minus sigma x by 2 sin 2 theta, tau xy plus tau xy cos 2 theta. So I am writing tau is equal to sigma y minus sigma x by 2 cos 2 sin 2 theta minus plus tau xy cos 2 theta. So if we equate this to 0, then we get sigma y minus sigma x by 2 sin 2 theta is equal to minus tau xy cos 2 theta, or sin 2 theta divided by cos 2 theta, that is tan 2 theta becomes minus tau xy by or minus 2 tau xy, these two will be multiplied here by sigma y minus sigma x is equal to, we can write 2 tau xy by sigma x minus sigma y. So we have got what is tan 2 theta value. Now geometrically we will see tan 2 theta or tan theta is equal to perpendicular by hypotenuse. Now this 2 tau xy, so that means perpendicular will be 2 tau xy if this angle is 2 theta, and base will be sigma x minus sigma y. So we have got geometrically this tan 2 theta is equal to 2 tau xy perpendicular by base value is sigma x minus sigma y. So then your hypotenuse becomes plus minus square root of this value square plus this value square, or we can write sigma x minus sigma y whole square plus 4 tau square xy. So if we could remove this cos 2 theta and sin 2 theta, then sigma n becomes so we can write sigma n will be equal to sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 into cos 2 theta, means base by hypotenuse, into we can write plus minus sigma x minus sigma y divided by square root of sigma x minus sigma y whole square plus 4 tau square xy. Then minus tau xy into sin 2 theta. Sin 2 theta is equal to perpendicular by hypotenuse. So we can write plus minus 2 tau xy divided by square root of sigma x minus sigma y whole square plus 4 tau square xy. So we have got sigma y value. So just mathematical expressions. So we'll solve this expression, sigma x plus sigma y by 2. So you can see sigma y minus sigma x into sigma x minus sigma y, and plus minus sign is there. So we can write directly here plus minus sigma x minus sigma y by y whole square by 2 into square root of sigma x minus sigma y whole square plus 4 tau square xy plus minus into minus, so that will be also plus minus 2 tau xy divided by square root of sigma x minus sigma y whole square plus 4 tau square xy. Okay, so now if we join these two, so that it will become sigma x plus sigma y by 2 plus minus these two will be multiplied here. So we can write sigma x minus sigma y whole square plus 4 tau square xy divided by, so half will be there, root over of sigma x minus sigma y whole square plus 4 tau square xy. And further simplification gives sigma x plus sigma y by 2 plus minus. So you can see, if this becomes a, this is square root a. This becomes, the numerator becomes a, then denominator is square root of a. So we can write plus minus half root over of sigma x minus sigma y whole square plus 4 tau square xy. So this is the value of sigma n we have got. Now it gives two values. When you consider plus, it will give one value. If we consider minus, it will give another value of principal stresses. So sigma n is equal to, we can write, we have got sigma x plus sigma y by 2 plus minus square root of half square root of sigma x minus sigma y by 2 sigma y whole square plus 4 tau square xy. So we have got these two value. Now when you consider plus, it will give one value, and we are denoting by sigma 1 is equal to sigma x plus sigma y by 2 plus half square root of sigma x minus sigma y whole square plus 4 tau square xy, and sigma 2 we will get sigma x plus sigma y by 2 minus half square root of sigma x plus minus sigma y whole square plus 4 tau square xy. So we have got two values of sigma, that is normal stress. So we have got two normal stress. One is having the maximum value, that is termed as major principal stress, and another one which will have less value or lower value, and that will be termed as minor principal stress. Minor principal stress. So from this, what we have got, in a stressed body, there are some planes where only normal stress exists, and that normal stress is given by sigma 1 and sigma 2. So what is principal stress? So we have seen principal plane. Now we will see what is principal stress. The principal stress, the stress which is acting on the principal plane, and that is also a normal stress. So in other way we can say the normal stress acts on a principal plane is called principal stress. The normal stress acts on a principal plane is known as principal stress. So for a two-dimensional body, there will be two such planes where only normal stress will exist. So that two planes are called the principal planes. They will be at an angle 90 degree with each other, and one plane contains the maximum stress, that is called major principal plane, and other plane which will contain the minimum principal stress, is known as minor principal plane. And for a three-dimensional body, there will be three such planes perpendicular to each other. So, there we will get three principal stresses, and we will denote by sigma 1, sigma 2 and sigma 3. But in two-dimensional cases, we will get two principal stresses, that is sigma 1 and sigma 2, and the value is given by sigma 1 is equal to sigma x plus sigma y by 2 plus half square root of sigma x minus sigma y whole square plus 4 tau square xy, and sigma 2 becomes sigma x plus sigma y by 2 minus half square root of sigma x minus sigma y whole square plus 4 tau square xy. Okay, that's all about this principal stress calculation by using analytical method. So, by using the formula, directly you can calculate sigma 1 and sigma 2 value. Okay, and other part of principal stress we will see in Mohr circle. How to find principal stresses by using Mohr circle. So, we will see in Mohr circle. So, before that, we will see another topic, that is how to derive the formula from a single formula. So, this is the most complex stress system. The figure shows the most complex stress system. So, from this we can derive all other cases, formula for all other cases. So, now we will see. So, for this we have to know the sign convention. So, sign convention. Otherwise, you can get the formula by deriving it. So, for derivation, you need some time. Only you remember this case, that is the third case what we have solved, and the result we have got sigma n and tau. Sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. And with this formula, you just remember the figure. In this figure, we have considered that sigma x is tensile, sigma y stress is tensile, tau is acting in anti-clockwise sense on x plane and clockwise sense on y plane, as well as the angle theta which makes, that is inclined plane makes an angle theta with x direction in anti-clockwise sense. So, this thing from the figure, so you have to remember the figure as well as this formula, then only the other cases can be obtained very easily from this derivation. Now, first we will see the sign convention. Sigma x and sigma y, if they are tensile stress, then we will write as positive stress. Okay, and if sigma x, sigma y is compressive stress, then we will consider as negative stress. Similarly, if tau is anti-clockwise, on any phase, that is, it may be on x phase or it may be on y phase. If tau is anti-clockwise, we will take as positive as per our convention, and if tau is clockwise, we will take as negative. So, these are the sign convention we have to remember. Then we will go for various cases. Let the first case or second case. Okay, let the body is under stresses. Okay, the body is under sigma x stress along x direction, the body is under sigma y stress along y direction, and shear stresses is 0, and the plane, inclined plane, makes an angle theta with x direction. So say this is the case, we have to find the formula for this case. So easily we can obtain, so by writing this, so we have got, for this case, we have got sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta, cos 2 theta minus tau xy sin 2 theta, and tau you have got sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. Now in this case, tau is not there on x phase as well as on y phase. So tau value is 0. Once tau value is 0, we can put tau value is 0, so this term will vanish. Similarly, in tau, this tau xy cos 2 theta also will vanish. So this will be the formula for this case. That means on inclined plane, sigma n and tau is developed. So that sigma n value can be expressed by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta, and tau value is given by sigma y minus sigma x by 2 sin 2 theta. Now we will see the another case. Say we are considering same case. The stress, shear stress is acting in clockwise sense on x phase, and on y phase it is anti-clockwise. Okay, this is given by this. So this is tau xy, tau xy. So now same formula we will write for this case, that is sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau is given by sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So that was the result of this. Now here you can see on x phase tau is in clockwise sense, but here tau is in anti-clockwise sense. So that means we have to put the value of tau, that is negative value. So if we put negative value, this will become plus and this will become minus. So this sigma n and tau will develop in this case. Now we'll see another case. Say this is the stressed element. Stressed element is under sigma x. Stress is compressive stress acting along x direction. Sigma x compressive stress. Sigma y is tensile stress. Okay, and the inclined plane is given as this, that is making theta angle with x direction in clockwise sense. So that means if we measure from x direction to the inclined plane, that angle becomes theta. So for this, what should be the sigma n and tau value? So to get the formula, so just we will write for this case, sigma n value is given by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta and tau is given by sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So that was the case result of this derivation. But for this case, what should be the equation? So we are going to write the equations from this. So now here you can see sigma x, instead of positive it is negative, here it is positive, here it is negative. So in place of plus sigma x we will write minus sigma x. So in place of plus sigma x we will write minus sigma x. Now shear stress is not available, so shear stress part we will remove from the equation. So shear stress is 0. So if we put shear stress 0, so this equation will become this. Now theta. So earlier we have taken theta as, in this case we have taken theta. Theta is the angle between the x direction and the inclined plane. But here theta is the angle between x direction and inclined plane, but in clockwise sense. Here it is in anti-clockwise sense, but in this case it is in clockwise sense. So from this equation, if we want to develop this equation, so we have to put what is the angle made by inclined plane with positive x direction, that is x direction. So this angle we have to put, that is this angle becomes 180 minus theta. So here 2 theta, instead of theta we will write 180 minus theta, and here also we will put 180 minus theta. So these equations sigma n and tau will be the equation for this case. Okay, so if the body is under sigma x compressive stress and sigma y tensile stress, and the inclined plane makes an angle theta with x direction in clockwise sense, then the equations for sigma n and tau will be sigma n is equal to minus sigma x plus sigma y by 2 plus sigma y plus sigma x by 2 cos 2 into 180 minus theta, and tau will be sigma y plus sigma x by 2 sin 2 into 180 minus theta. Now we will see another case. Say this is the case in which, say, sigma y is compressive stress and sigma x is tensile stress, and also the angle made by the inclined plane with x direction in clockwise sense as theta. Also the shear stresses acting on x face as clockwise, and on y face it is anti-clockwise. That is tau xy. Now for this case, what should be sigma n and tau value? So we are going to just write the formula for this. So for writing the formula, we will just write the formula for the most complex case, that is sigma n was given by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta, and tau was given by sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So this was the case. Now 1 by 1 will change. Sigma x is positive, so no change. Sigma y is negative here. So when sigma y is negative, so we will write sigma y instead of positive, we will write negative sign. Similarly, negative sign will come here. And here also it will be negative sign. So one amendment is done. Next amendment is tau. In this case, tau is in anti-clockwise sense, but here tau is in clockwise sense. So clockwise sense. So we have to put the negative value for tau. So instead of minus, so it will be minus into minus plus. Similarly, this one will be plus into minus. So this will be minus. Now we will go for theta. Theta. So theta, for this case, theta is the angle between the positive x direction and the inclined plane. So what is the theta value for this case with positive x direction? So this is 180 minus theta. So we will substitute this value instead of theta. So 180 minus theta. So instead of theta, we will write into 180 minus theta. And sin 2 theta, here we will write 2 into 180 minus theta. And similarly here, sin 2 theta, 2 into 180 minus theta. And for this, 2 into 180 minus theta. So this will be the result for this case. Sigma n value is given by sigma x minus sigma y by 2 plus minus sigma y minus sigma x by 2 cos 2 of 180 minus theta and tau xy sin 2 into 180 minus theta. That is the sigma n value. And tau value is minus sigma x minus sigma y minus sigma x by 2 sin 2 into 180 minus theta minus tau xy cos 2 into 180 minus theta. So I hope some of your doubts are clear. So by remembering this case, we can develop the formula for any case. So by varying, we have to only remember the sign conventions for direct stress as well as shear stress, as well as the angle by which the inclined plane we are considering. Okay friends, that's all for this video, and I hope this will clear your doubts. And if you think that this video is valuable or clears your doubt, please do subscribe as well as like and share the video. Thank you for today, and we will meet you soon in the next video.